All right, math family, we're going to keep going. We're going to be talking about radical equations today. So, radical equations are equations where you have radicals, and specifically, the variable is underneath a radical. So, radical equations, as we solve them, are going to be similar. We're going to work to isolate our variable. And again, we're going to in addition to isolating the variable, we want to isolate the radical because the variable is going to be underneath the radical. So really, we want to think first about isolating the radical, then isolating the variable. But on Wednesday, we're going to get into how do you graph these functions. And these functions are pretty interesting because their domains are going to be really specific. Because if we think about this, if we have an x underneath a radical, there are a lot of values that cannot be true for this value of x. Because if we're under a square root here, we know that all of our negative numbers are not valid. So when we're thinking about our graphs of radical equations, they're going to look different than lots of the graphs that you are used to seeing because their domains are so isolated. So radicals on one side. So this is kind of like the basic beginning way to solve a radical equation. And a lot of you probably can think about this one intuitively. So we want to get our variable by itself. We want to get our radical by itself. In this case, it's the same thing. So I'm going to subtract 3 from both sides. So here I have the square root of x, and here I have 7. So right now I want to get x. Well, right now I have the square root of x. I know that the inverse of taking the square root of something is to square it. So if I square this side and I square this side, on this side I have x, and I know that 7 squared is 49, so that's going to give us an x value of 49. So it is really important when you're solving a radical equation that you check your solutions because as we get into some more complicated values, we're going to be looking at things called extraneous solutions. And those are solutions that are created mathematically through the process of solving the equation. But then when you go back into the equation to test them, they actually don't work. So we just want to get into the practice of checking our solutions with radicals always. So the square root of x plus 3 equals 10. The square root of 49 plus 3 equals 10. That's 7 plus 3 equals 10. And that is correct. So again, right now, this might seem really silly, but by the end of this lesson, you'll see why we're doing it. So again, one of those things is just like when you build a habit, the only way you're going to build it is if you do it every time. So if you think, well, I'm only going to check it when there's an extraneous solution, well, how are you going to, that's just not going to work. That's not how our minds work. So what we're going to do now is we want to get this radical by itself. So I'm going to divide by -3, and I'm going to divide by -3. So I get that the square root of x is equal to -18 divided by -3. So that's 6. I need to get x by itself here. I got to get it out from underneath the square root. So I square it, and I get that x is equal to 6 squared, which is 36. Again, good practice says that I check my solution. I've got -3 multiplied by the square root of x equals -18. So that's -3 multiplied by the square root of 36 equals -18. That's -3 times 6 equals -18, and we are good to go. So we've got one more where we only have radicals on one side. So let's go ahead and get that one done. So this one just puts together the things in the first step. So I'm going to separate my equation out. And then we're still going to follow the correct order of operations as if we were solving a normal equation. So think about what if this were just 2x minus 5. Well, to root x minus 5 is going to require me to um, first move this piece, then get that coefficient off. So I'm going to add 5 here. So that's going to give me 2 times the square root of x is equal to -1 plus 5. That's 4. Now I'm going to divide my coefficient of 2 off on both sides. So I get that the square root of x is equal to 4 divided by 2, which is 2. So the next thing that I need to do is get this x out from underneath the radical. So I'm going to square both sides. And again, I'm squaring it because it's a square root. If it were a cubed root, I'd be cubing it. But this is going to give me x, and then 2 squared gives me 4. So I think I've got a solution of x equals 4, but I'm going to come verify 2 root x minus 5 equals -1. So that's 2 times the square root of 4 minus 5 equals -1. That's 2 times 2 minus 5 equals -1. That's 4 minus 5 equals -1. And again, we are good to go. So we're going to move on to something a tiny bit more challenging. All right, so I'm just kidding. These ones aren't actually any harder, only because all of the expression for each one is underneath the radical. So you'll see they get a little trickier. So right now, I go to solve, I realize that this entire piece is under a square root. This entire piece of this entire expression is underneath the square root. So to get started, I am just going to square both sides. Since what I do to one side, I can do to the other, and we're good. So here, this is just going to become x plus 4, and this is just going to become 2x minus 1. Because remember, if you square a square root, what happens is whatever is underneath that radical is what comes out. So I'm looking at an equation with variables on both sides. I want x, so I'm going to move this x, keep my x values positive. Then I'm going to add 1 here, add 1 here. So that's going to give me 5 is equal to x. So again, I think I have an answer, but I'm going to check it. So the square root of 5 plus 4 should be equal to the square root of 2 times 5 minus 1. Well, 5 plus 4 is 9, so that's the square root of 9 should be equal to 2 times 5, 10 minus 1. Well, that is also 9, so we've got 3 is equal to 3, and we are good to go. So right there, we do have a solution of x is equal to 5. All right, so moving on to example 5 here, we have pretty much the exact same situation. I've got an entire expression under a square root, an entire expression under a square root. So I'm just going to square both sides. Yeah, I'm sorry, when you write little numbers with this thing, it's just, or like small symbols, so like exponents or subtraction signs, they just sometimes don't exist. All right, so this is going to give us 3x plus 8 is equal to x plus 4. When I solve for x, I'm going to subtract x from both sides. So I'm going to get 2x plus 8 is equal to 4. Move my 8. And I get that 2x is equal to -4, so I divide by 2. And I get that x is equal to -2. All right, so I want to check my answer here. I didn't leave myself a lot of room to do that. Oh, wait, look at me. I can go down. Look at teaching online school, and I didn't even know I could scroll. All right, so I'm going to check my answer here. And this is going to be the square root of 3 times -2 plus 8 is equal to the square root of -2 plus 4. All right, let's keep going here. So this is going to give me the square root of -6 plus 8. This is going to give me the square root of -2 plus 4. It's going to give me that the square root of 2 is equal to the square root of 2. And while that is an irrational value, we'd have to use our calculators to figure it out specifically what it was. And even then, the square root of 2 is the most accurate way to say the answer, because anytime you give a decimal approximation, that's what you're doing. You're approximating it. But at this point, this is your most simple solution. Even though it's an irrational value, it's still true that the square root of 2 is equal to the square root of 2. All right, guys, so this is where those extraneous solutions that I've been referencing are finally going to start showing up. And you might notice that these are a little different. So we've got variables on both sides, but we only have a radical on one side. So that's going to get interesting. So this is one of those times when like all of the things that you've learned in my class, in math one and now math two, and last unit and this unit, everything's going to come together and it's going to be like, oh, math's so wonderful. This is one of those moments because right now we're solving for x. Well, let's see what happens. So we know that we've got to get rid of this radical. So ultimately, anytime you are solving an equation, you can't have a radical in the end. So what I have to do is I have to square both sides. So I'm going to have x squared on this side. I'm going to square these. So I have x squared is equal to 42 minus x. Now, some of us are probably having a conniption right now. We're like, oh my gosh, this is impossible. No, it's not. You are solving something where you have a squared value, an x value, and then a constant. You are looking at a quadratic. So to solve a quadratic, we got to get everything set equal to 0 because I'm assuming that there aren't a lot of us like jumping up and down right now excited about completing the square. So I assume we're going to be factoring. So I'm going to always keep the a value on my x positive. So that's going to be x squared. Right now I have a negative x. I need to bring it to the other side. So I'm adding x to both sides. So that's going to be plus x. And then I'm going to take my 42. It's positive, so I need to move it. So I'm going to subtract it, minus 42. Good, we've got easy numbers because we should already know what they are. Because we need things that multiply together to give us negative 42. So they're going to be consecutive numbers because they add to positive 1. So they can only be 1 away from each other if that's what they add to. And then they've got to be a positive and a negative. So let's say we should know we've got 7 and negative 6. So at this point, I'm going to say that this whole piece here, x squared plus x minus 42, is actually x plus 7 times x minus 6. And that stuff's all equal to 0. So now I'm going to solve my equation by saying that x plus 7 equals 0. So that's a possibility of x is equal to negative 7. And then x minus 6 equals 0. So that's a possibility for x to equal 6. All right. So anytime you are dealing with a radical equation, you can have both of the answers be correct. So it's possible that that and that are also going to give us perfectly acceptable solutions. It's also possible that one of them works. So one of them might check out as true, one of them might not. And then it's also possible that neither of them are true. So that's where things get a little bit interesting. So our original equation is x is equal to the square root of 42 minus x. So the first thing that I'm going to do is I'm going to check my first value. So I'm going to check x is equal to negative 7. So right now my x becomes negative 7. Negative 7 is equal to the square root of 42 minus negative 7. So that's that negative 7 is equal to the square root of 49. All right, so this is where some of us are going to get annoyed because it is true that negative 7 times negative 7 squared gives you 49. But remember that a square root can't be negative. So it's not true that the square root of 49 is negative 7. The square root of 49 is positive 7. So again, you can't have a negative value under here. So it's not as though this was negative 7 times negative 7. So right now we've got that negative 7 is equal to 7. That's not true. And so x equals negative 7 is not going to work here. And if you go back and really look at the equation, that makes sense because this right here is telling us that a negative value is going to be equal to some square root. Well, the value of a square root can't be negative, so it doesn't make sense for that to be negative 7. So let's go look at 6 now. So now we're checking x equals 6. Okay, so that's going to be 6 is equal to the square root of 42 minus 6. So 6 is equal to the square root of 36. Well, the square root of 36 is 6, so that says that 6 is equal to 6, which is accurate. So when we go to look here, even though it looks like we had two solutions here, this one is called an extraneous solution. You do not include it. You don't even say this one's extraneous. No, it's just not a solution unless it asks you to list an extraneous solution. So the answer to this equation is that x is equal to 6. That's it. All right, so let's go look at the next one. So the next one is going to be even more fun. Some of you already see it because when you look at this, the first step is going to be to square both sides. Well, this is not equal to, it is not equal to x squared plus 16 because that's wrong, because this is x plus 4 times x plus 4. So what do we have to do here is we have to FOIL. Yay! Okay, so on this side we have 2 minus x. Because when I square what's under the radical, I get what's under the radical, so I get 2 minus x. Here I get, I have to FOIL. So on this side I still have 2 minus x. Here I get x squared plus 4x plus 4x plus 16. So I get that 2 minus x is equal to x squared plus 8x plus 16. Now, in order to solve this, I need it to be equal to 0, and I want this piece to be positive, so I'm going to take these pieces, move them over here. So I'm going to add x, and I'm going to subtract 2. That gives us 14. Okay, 7 and 2, great. All right, so those are gone, so this gives me 0. So I get x squared plus 9x minus 4 plus 14. So at this point, I know that this piece has to be equal to 0. So I'm going to factor this to solve, because that's one of the ways that I know how to solve a quadratic equation. So they need to multiply to give me 14, but add to 9, so that's 7 and 2. So I've got x plus 7 and x plus 2. So that gives me x plus 7 equals 0 and x plus 2 equals 0. So I've got x equals negative 7, maybe, and x equals negative 2, maybe. All right, let's see what happens. So I've got the square root of 2 minus x, square root of 2 minus x is equal to x plus 4. All right. So again, I've got to check my solutions here. So I'm going to check x equals negative 7. So that would be that the square root of 2 minus negative 7 is equal to negative 7 plus 4. So that's that the square root of 9 is equal to negative 3. Well, the value of a square root can't be negative, so that's 3 equals negative 3. That's no good there. So I'm going to go up here, and I already know that negative 7 is not good. There's not some like magical thing about negative 7 not working for rational equations, so that's just bizarre that that's what happened both times. All right, so let's check negative 2. So that's going to be the square root of 2 minus negative 2 is equal to negative 2 plus 4. So that's going to give us that the square root of 4 is equal to positive 2. Well, that looks good because the square root of 4 is 2, and 2 is equal to 2. So I'd go back up here, and I have one solution. My one solution is that x is equal to negative 2. Now, again, it is possible that you go and you plug them in to check for extraneous solutions and you get that both of the x values are true. That is completely possible. You're going to see that in your homework assignment that you're about to get. And then it's also completely possible that you plug them both in and neither one of them work. So you're going to have a Delta Math assignment on this, but if you hang tight, I'm going to go to that site right now and show you specifically some not tricks, some information about how to enter your solutions here and such. So here we go. So your next assignment for Delta Math is going to be Radical Equations Review. So if you go to Delta Math, you'll see that. You'll click it, and then I think multiple little things are going to come in, or it's going to go to another page because I'm going to build in multiple pieces here. So the one that you're going to be doing right now is Intro to Radical Equations. So that's what you're doing right now. So when you go to put your answers in, again, when you're solving equations here, you're solving for x values. So again, this one was one that has two solutions. So at the bottom of your screen, it'll say, like, well, I can show you what it'll say. Ooh, maybe. It'll say, look at math, look at technology happening. Oh, wait, I know how to do it. I just click it. Oh, no, bad. Oh yeah. So at the bottom, you'll go here and you'll just type your answer. So if you think it's 9, you put 9. If you think there's two solutions, you'll do 9, comma, and it'll set up a space for you to put in another answer. So again, if you think there's two x values, you put one there, you put one there. If you think there's only one, then you apparently, if you hit that little subtraction sign, it'll go back to that one solution and you're good to go. If you go in and you test both of your values and neither one of your values is true, you just submit it as a blank thing. Like you don't type in no solution, you don't type in 0, because if you type in 0, you're saying that the answer is 0, so don't do that. You just put in nothing. Like if you think if you test both solutions and they're both false, you just hit that and you just turn in nothing. So again, if you have two solutions, you put in two solutions. This is not, we're not solving for where something intersects, so you don't have to put in an ordered pair. These are both x values. Then this is an example. If you just put in nothing, it shows up as nothing. Well, that's what happens. It says, well, this one's wrong, you rejected it. This one's wrong, you rejected it. So you put in nothing because there's no solution. And then this is an example where one of them's false, one of them's true. So like 8 was true. So that's the one that they put in there. So again, those are the ways that that's going to work there. So that's going to be your homework assignment for this lesson. Then the next thing that will happen is Tuesday night, you're going to have, or Tuesday, I'm going to post another lesson, which is just reviewing, which is solving more radical equations. It's going to come from your Walsh book. I think it's Walsh lesson 3.4, maybe. But let's see. Yeah, it is Walsh lesson 3.4. And if you look at that, the radicals have gotten, or the equations are just a little bit more complicated. So the ones that we're looking at are by no means like super simple, but they are, it does get a little more challenging. So if you look at like the description in your Delta Math, you see like level 1, and then some of them are level 2. Well, this goes up to level 4, and I would say the Walsh lesson is just going to kick us up into those 3, 4 level questions. So, and again, the only thing that's going to get more difficult is the radical work. So, looking through the Delta Math assignment list, most of you guys are great. Most of you have completed everything you're supposed to. Some of you guys missed one in the whole like excitement or whatever this is of getting this online situation started. I just want to alert you. Most of you have done both of these, but some of you missed radical operations practice. That was kind of the first one assigned before there was any sort of lesson to go along with it. That was just review of stuff that we had already done when we were still together and physically still together. And then this one, a lot of you have done this one. This was it was to be done after Walsh lesson 3.3 to kind of prepare you for that lesson 6.4 that I emailed you, and then you had that assignment. So make sure you did that one. That one was really quick. I think everyone got them all right. I think maybe some of you might have typed something wrong and missed one, but obviously those are good to go. And then this one here is the one that I just told you about. So no one's done that one yet. because you wouldn't know to. But again, make sure you've done both of these because a lot of you have done both of them, but a couple of you have done one, not the other. And I just want to make sure that you know they're both there. There's only like one or two of you that haven't done either, but chances are if you haven't done those, you also aren't watching this video. So hopefully we'll get that together soon. All right, I miss you guys a lot. It's super boring. It's just me and the dog and the TV and books and walking, lots and lots of walking. Hope you guys are good. Bye.